So in section 11.4 of chapter 11, we learn how to apply the Pythagorean theorem and its converse to learn things about a right triangle, like we can find a side length, or we can also use it to determine whether a triangle is a right triangle. So a couple of reminders about the right triangle. We have a hypotenuse, which is always the longest side, and it's always going to be across from the 90-degree angle. And then we have two legs of a triangle. So the hypotenuse is always going to be the longest one, and the two legs, one could be shorter, one could be longer, depending on what we have. They could also be the same length, but the main thing is the hypotenuse has to be the longest side. So there's a theorem called the Pythagorean theorem that allows you to connect all the lengths together, and the theorem tells you that if you square the side length of one leg and you add the square of the other side length for the other leg, it's going to be equal to the square of the length of the hypotenuse. Most commonly, you guys remember it as a squared plus b squared equals c squared, where c has to be the hypotenuse. So what we could do is we can use the theorem to find unknown length. So the first thing I'm going to do is I'm going to write down the Pythagorean theorem, and I'm going to use the information given to replace things in the equation. So I don't know the a, so I have to keep it as a squared. I do know that b is 6, so I'm going to say plus 6 squared, and it's equal to c squared, and c is given to me that it's 7 squared. So what we're going to do first is we're going to square the numbers, and we get a squared plus 36 is equal to 49. So this is basically an equation, a quadratic equation that we're trying to solve, where we just have a variable squared by itself. So all we need to do is we need to isolate it, and we're going to do that by subtracting 36. And we get a squared is equal to 13. And then if I'm interested in just the a, not a squared, I'm going to take a square root of both sides. And I get a is equal to plus or minus square root of 13. Now we always want to check whether our answer makes sense in the context for this problem. So a is the measurement of the length, or it's the length of a side. So I would not use the negative answer. I would only use the positive answer. So my answer will be a is equal to positive square root of 13. Alright, so pause the video and try this this guided practice on your own to see if you can apply the Pythagorean theorem. Alright, the answer should come out to be 13. You can see the work here, and if you didn't get 13, then I recommend going back to example 1 and rewatching it again. So we can also make it more difficult by using, I guess, setting up a word problem in here. So, okay. What we're going to do is we're going to read the description of what's given to us, and then we're going to fill out our diagrams. It says a right triangle has one leg that is 2 inches longer than the other leg. So I'm going to pick one leg, and remember, A and B are your legs, so you can use A or B. So I'm going to use A here, and I'm using the shorter side because the other leg is 2 inches longer, which means I'm going to say it's A plus 2. The length of the hypotenuse is square root of 10. So the hypotenuse is square root of 10, which is right here. Find the unknown lengths. So the first thing I'm going to do is I'm going to write down the Pythagorean theorem. So a squared plus b squared is equal to c squared. And then I'm going to use my diagram to replace a, b, and c. So I'm going to use the leg with side length a for a. B would be a plus 2 squared, and c is going to be square root of 10 squared. And on the right side, if I square square root of 10, I just get a 10, and then on the left side, I'm going to multiply this out. So we have a squared plus, and we have a plus 2 times a plus 2. We're going to very carefully distribute it, and we get a squared plus a squared plus 2a plus 2a plus 4, and it's equal to 10. if I combine my terms, I get 2a squared plus 4a plus 4 is equal to 10. So as soon as you see a squared and an a, you know that it's going to be a quadratic equation where you either would factor or use a quadratic formula. So our first step is to set it equal to 0. So I'm going to subtract 10 from both sides, and we get 2a squared plus 4a minus 6 is equal to 0. I notice that all my numbers are even, which means that I can go ahead and divide through by 2 to make my numbers nicer and smaller. So I get a squared plus 2a minus 3 is equal to 0. I'm hoping that I can factor, because that would be the easiest way to solve this. So if my first term is a squared, I know I'm going to start with an a and an a. And I need two numbers. I need to multiply to negative 3. But when you add them together, they have to give me 2. So these two numbers are going to be negative 1 and a positive 3. So I get two answers. A is equal to 1 or A is equal to negative 3. So remember that A is the length of one of the sides of a triangle, and we can't have a negative length. So we would not use the negative 3 as an answer, but would use A equals 1. And then we're going to go back and we're going to read the question, and it says find the unknown lengths. So A is 2 or 1, which means that A plus 2 would actually be equal to 3. So these are two unknown side lengths. 1 inch is the one, and 3 inches. Alright, so pause the video and try this guided practice on your own to see if you understood it. Alright, so hopefully you got 9 inches and 12 inches as the two answers for the two unknown lengths. Okay, so one way to use the Pythagorean theorem is to find this missing side length, but another way to use it is to use the lengths of the three given sides to determine if the triangle is a right triangle. And the only way it's going to be a right triangle would be if this equation is true. So if you take your two shorter sides, you square them, you find the sum of the squares, and you set it equal to the longest side squared. If this is actually going to be true, then your triangle is in fact a right triangle. So here's a couple examples. The first thing you always want to do is you want to label your A, B, and C always has to be the longest side. And it might not be the last one, it might be in the middle, but you always scan through to find the longest. In this case, 17 is the longest side, so this has to be C. Now A and B could be any, A and B could be changed, so as long as the two shortest sides are A and B, then that's all we need to do. So we need to check whether A squared plus B squared is equal to C squared. And I'm putting in question mark because we don't actually know that they're equal. So first we square E, and then we add 15 squared, and we want to see if it's going to be equal to 17 squared. And 17 squared is going to be 289. 8 squared is going to be 64, and 15 squared is going to be 225. So if I add 64 and 225, I do get 289, which means that it's true, so I do have a right triangle. Yes, it is a right triangle. Okay. So here's another one for us. We first going to find the longest side. So we have 5, 8, and 9. So 9 would have to be the hypotenuse, or C in our case. And then 5 and 8 could be the A and the B. And again, we want to check if our equation for the Pythagorean theorem is going to hold true. So A squared is 25, B squared is 64, and C squared is going to be 81. And again, I don't actually know if it's equal, so I'm going to put a question mark here. So 25 plus 64 is going to give us 89, which is not equal to 81. So if these two, if the left side is not equal to the right side, then we do not have a right triangle. So no it is not a right triangle. Alright, so here's our last example where we're going to apply Pythagorean theorem to a real-world situation. We have a problem where a construction worker is making sure that one corner of the foundation of a house is a right angle. So he has this wall, and he wants to make sure that this is a right angle. And he makes a mark 8 feet from the corner along one wall. So here's our 8 feet. And then he marks another one 6 feet. Then he measures the distance between the two marks, which is the hypotenuse, if it is a right triangle. And he gets the length to be 10 feet. So he wants to know, is this a right angle? So it would be a right angle if we have a right triangle. And to check whether we have a right triangle, we have to check whether the Pythagorean theorem is going to hold true. So the first thing we need to do is label A, B, and C. So C is the longest side, so this would be C, this would be A, and this would be B. So we want to check whether A squared plus B squared is actually equal to C squared. So I get 64 plus 36 is equal to 100. And again, we don't actually know that it's going to work, so I'm going to put a question mark here. 64 plus 36 is going to give me 100, which means that, yes, we have a right triangle. Which means that the angle that we're measuring is also a right angle. So yes, the corner is a right angle. Alright, so these are the last 4 problems for you to try on your own to see if you understood it. Alright, so hopefully you got that the triangle described in number 4 is not a right triangle. The triangle described in number 5 is a right triangle. The triangle described in number 6 is also a right triangle. And then for number 7, the worker who made a triangle that is not a right triangle because the Pythagorean theorem doesn't actually